Hello, my name is Mr. Chunya. Welcome to my study room. Today, I'm solving objective questions 19, 31, 38, 39, and 50 of the 2024 WASSCE Core or General Mathematics paper written by Ghana. I choose to put these questions together because they are all under the same topic, Circle Theorems. We move on straight to question 19, which has a diagram that is not drawn to scale. And the instruction reads that in the diagram, segment PR is the diameter of the circle PQRS with center O. Find the value of angle PQS. And we start by taking the various information or key points given in the problem. The first information that is worth noting is that PR is the diameter of the circle. And another information is what we are solving for, the value of angle PQS. And this is angle PQS here. Maybe let's call it X. Alright. Now let's come back to the first information that PR is the diameter to the circle. If PR is the diameter to the circle, then it means that this angle here is 90 degrees because according to one of the circle theorems, a diameter subtends or makes an angle of 90 degrees at the circumference of the circle. And since this side, that is SR and SP or PS, have the same marking, meaning that they are equal or congruent. And if that is the case, then it means that triangle PSR is an isosceles triangle. And that means that angle SPR and angle PRS will each be 45 degrees. Let me just write that quickly. Alright, so this is what we're saying. This is angle SPR. So this is 45 degrees. And then this is PRS. Also 45 degrees. And now we'll be taking this chord PS here. And then taking that chord, we see that that chord subtends an angle at R here. And the same chord subtends the angle we're solving for, which is PQS. And one of the circle theorems says that angles subtended by the same chord in the same segment are equal. So it means that since angle PRS is 45 degrees, angle PQS will also be 45 degrees. Let me write that quickly. And looking through the options, the correct answer is option B. But then, as we know, with geometry problems, we can use another approach or different approaches in solving and getting the same answer. For example, we can use the idea of arc measures. Let's move on to the next problem, which is question 31. Question 31 also has a diagram that is not drawn to scale, and the question reads that the diagram shows a triangle MNP inscribed in a circle. Segment MQ is a tangent to the circle at M. Find angle MPN, and these are the key facts from this problem. The segment MQ is a tangent, and then also the angle MPN, which we are solving for. Let's make it X, which is the angle we are solving for. We'll start right from the information that MQ is a tangent. If MQ is a tangent, then it means that the angle QMP, which is the 73 here, will be equal to the angle MNP, which is right here. So here will be 73 degrees because the angle between a tangent and a chord is equal to the angle that chord subtends in the opposite segment of the circle. Let me just state that for reference. Now that we know this, we are just going to use the triangle sum theorem, which says that when you add all three angles in the triangle, it should be equal to 180 degrees. Let's set it up. So that means that angle PMN, which is a 58 here, plus angle MNP, which is a 73 here, and then plus angle MPN, which is the RX, the angle we're solving for, should be equal to 180 degrees. Let me set it up. I just wrote everything I've said so far. Angle PMN is 58 right here, plus angle MNP 73, then angle MPN, which is what we're solving for, is X. And 58 plus 73 is 131 plus X equals 180, and 180 minus 131 is 49. That means the correct option to this problem is option B. Let's move to the next question, which is 38. Question 38 and 39 are together with the same diagram. And the question reads that in the diagram, segment PR is a tangent to the circle at Q. The center of the circle is O and angle QOS is 108 degrees. As always, the diagram is not drawn to scale. Let's take the information that we have in the problem. The first one is that PR is a tangent to the circle and the center of the circle is O. And that is where we'll start from. If the center of the circle is O, then it means that OS and then QO or OQ are radii to the circle. Each of them is the radius to the circle. It means they are equal. And that also means that triangle QOS is an isosceles triangle, right? And that will also mean that this angle here and that angle there will be equal. I didn't read question 38, so we should find angle OSQ, which is this angle here. Let me make it X. OXQ. And we said that they are equal, so that means that here will also be X, right? Good. Let me write everything I've said so far. Right. Putting everything I said together, triangle QOS definitely is isosceles, so that means that these two angles are equal. So instead of writing each of them separately, I decided to write 2 angle OSQ plus 108 equals 180 degrees, which is the triangle sum theorem, right? Let me just write that. And then substituting X in place of angle OSQ and subtracting 108 from both sides, 2x will be equal to 72. And then dividing both sides by 2, x will be equal to 36, which makes C the correct option to the problem. Then we go to question 39, where we have to find angle SQR. Angle SQR is right here. And before we solve that, let's get our mind back to one of the circle theorems, that the angle between a tangent and a segment or chord through the center of the circle is 90 degrees. That means that this angle here is 90 degrees. The angle between QR and then QO is 90 degrees. So let me write that first. Right, so angle OSQ, which is the angle we got for question 38, will be equal to OQS, which we stated clearly in the diagram already, and that is 36 degrees. And now angle OQR, which is the 90 degrees we stated earlier here, will be equal to OQS, which we know to be 36, plus SQR, which is what we are solving for. So substituting the numbers, it means that SQR will be equal to OQR, which is 90 degrees, minus the 36, which is OQS. and that will give us 54 degrees, and that is option C. Now let's take question 50, which is the last for this study. Question 50 still has a diagram which is not drawn to scale, and it reads that in the diagram PQR is a circle with center O and angle OQR is 42 degrees. Find angle QPR, and let's show that this is angle QPR. We'll start with the idea that the center is O, and if the center is O, then it means that this segment and this are equal, because each of them will be a radius to the circle. And if they are equal, it means that triangle QOR or RQO is an isosceles triangle. So that means that this angle will also be 42 degrees. And this angle here will be 180 minus 84 degrees, which will be 96 degrees. And then one of the circle theorems says that the angle subtended at the circumference of a circle by a chord is half the angle it subtends at the center of the circle. Or putting it in another way, the angle inscribed by a chord is half the central angle that chord makes. So that means that x will be equal to half of 96, which is 48 degrees, and that is option A. But then if you want to go procedurally, I'm going to write all of that quickly and explain. So there you have it. Angle OQR equals angle ORQ, which is 42 degrees. And then using the triangle sum theorem, angle QOR, which is a central angle, plus twice angle OQR, which is 42, should be 180 degrees. So 2 times 42 gives us 84. 180 degrees minus 84 is 96, and then by that theorem, this angle will be half of the 96, and that is 48. I hope this lesson has been of help to you. If yes, then kindly consider subscribing to this channel for more videos like this. Till we meet again, bye bye.